Let's go through question 4b, which is about the fetch, decode, execute cycle and the structure of a CPU. So if we draw the components of a CPU, we're going to have the immediate access store, or the RAM, or the memory. We're going to have the CPU, and then the system bus connects the CPU and the RAM. The system bus is made up of 3 buses. You have the address bus, you have the data bus, and you have the control bus. And then it's saying that some of these buses, so we need to know what a bus is. A bus is just lots of connecting cables. So if it's a 32-bit CPU, we're going to have 32 copper tracks or 32 ways of connecting across here. So a bus is just lots of connections to transfer lots of bits. And then a bus can be bidirectional or unidirectional. So bidirectional, bi like bicycle, means two ways, 2 directions. Unidirectional like unicycle, 1 wheel, 1 direction. So most of these buses are unidirectional. So the data bus, data can go in both directions. The control bus, signals can flow in both directions. But the address bus only ever goes from the CPU to the RAM. We've got to give a reason. It's got to be a description, 2 marks, why that's the case. So we need to understand it a little bit more. Well, let's go through fetch, decode, and execute. Fetch means you've got your program counter in here that stores the address of the next instruction. That program counter, when you switch your computer on, is probably going to be set to 0. So you'll put that value, 0, the address of the next instruction, on the address bus to send the address to RAM. Then you put a little signal on the control bus to say, okay, RAM, I want you to actually start reading. RAM will receive that control signal and say, oh, I need to read. Where do I need to read from? Let's look on the address bus. And then it will find the value at address 0. Whatever that value is, it will put it on the data bus from RAM to the CPU. The CPU's then received that value and it will store it in the instruction register. And it will increase the program counter so that we can look at the next location next time. That's fetch done. Decode means we'll look at the value in the instruction register, and is it going to be add, subtract, store, load, whatever it is. If it's a load instruction, then we need to fetch something else from RAM at this point. It's basically decode is saying, what does that instruction mean? Get ready to execute it. And then the execute stage says, right, I want to actually carry this out, make it happen. So if it's an add instruction, we need to get some data to add, and we need to add it using the ALU, the arithmetic logic unit, and the accumulator. So whatever value is stored in the accumulator is going to be added to a value in the data that comes across the data bus, and we store the result back into the accumulator. It's basically carrying out the instruction. So far we've only ever seen addresses go in this direction, we've only ever seen data flowing in this direction, and we've only ever seen signals flowing in this direction. How can we get signals happening in the other direction? Well, RAM needs to tell the CPU when it's finished reading and when it's put the value onto the data bus. And what happens if you have a store instruction that says, I have a value in the accumulator and I want to store it in RAM? In that case, the CPU needs to say where to store it. It needs to send the actual value across the data bus and send a signal to make it happen. And then that value will be stored into RAM. But at no point does the RAM say, this is where I've read from, or this is where, it just doesn't put anything onto the address bus. So the address bus is the only unidirectional bus for those reasons.